And literally it was almost as small as this. We were both changing a file. We were both just adding a different attribute to CSS. It was a little more text than this, but we were just trying to change various things. It wasn't even that we were changing the same things, but we didn't know about each other's changes. So version control helps you take care of that. Version control is a lifesaver in terms of having lost files, having not remembered, having said, how many of us have said, we fixed this a month ago and I don't remember what we did, but we did something and now we can go back and try and figure out what it was. Version control also helps with that because you get to annotate what you save. So you can have notes in it to remember why you saved it that way and what may have worked or what may not have. We're not going to talk much about anything but Git today, but I just wanted to mention a lot of us use SVN or have used SVN. Drupal used to use CVS, but has since moved to Git. SVN and CVS, not the only difference. The biggest difference is that you have to be connected to the server to be working to actually commit and save a file, and the others, the distributed model, Git especially, you don't. You don't have to be connected to anything except your own machine to do anything, and then you can sync the changes later, which is really nice. Means you don't have to be permanently on the internet. It means you can make changes and get rid of them without anyone ever having seen the monstrosity that you just tried to build. So for a client-server model, everybody's talking to the same SVN server. That helps. That's amazing because then everybody is making sure they're always working on the same sets of files. There's no confusion. But again, it ties you to that cloud and you have to be able to do it that way. So in distributed model, what's on my laptop is all I need. It's the whole Git repo. It's everything that's going on for me. Pat's machine may have a copy of it and we can sync our changes back and forth. Git doesn't really care that one of you is a server or one of you is a dedicated machine for what we call the remote. It really just is able to say, I would like to sync to Pat, Pat would like to sync to me. And we've done this on a couple of projects, but typically what happens is you get a remote repository, often GitHub. GitHub is not Git. It is a company that has promoted the use of Git a lot. And done some amazing things with the UI, and hopefully we can get there, and with the teams and sharing and how you deal with Git repositories. But you don't need GitHub, you don't need Bitbucket, you don't need anything but the Git client itself to be able to work on things and to be able to share your Git repositories with other people. Git does a nice thing where, let me just stay here for a sec. Git does a nice thing where it does not, unlike CVS or SVN, it does not try to enforce any authentication. That's all done by other mechanisms. So SSH or GitHub has its own permissions or however you set up. If you can connect, it assumes if you can connect and talk, that's all we need. So it lets all the other systems that are good at that try and handle it. So Git doesn't have to worry about passwords and all of that. Any questions? 9 a.m., first session. Don't be shy. So the nice thing about both of these systems, the same for Git, is that the web server, where you're actually serving the files from, is really just another client. It's just another place that the files get checked out. It doesn't really act much differently, except usually it has some different permissions, or if you're at Pantheon or Acquia, you do those gits, and then we do things to help move the files into the right place. But the web server really, is no different than my local machine, except it's connected to the internet with the web address and set up correctly for lots of traffic. Getting started with Git has gotten 1,000 times easier since the first time I did this session. The Git SCM download. So Git SCM is like the official Git people. They're the ones who, this was built for the Linux kernel project by Linus Torvalds, so it's really tied to Linux, but they've gotten to the point where they realize, well, Mac and Windows users, need to not be second class. It was easier for the Mac being built on the Unix platform, but now the Git SCM downloads has overtaken all of the other Windows applications for Git. So just go there, there's clients you install, and they give you everything you need to be able to get Git up and running and connect to things like GitHub or Bitbucket, or if you have your own internal servers. So on the Mac, they have a Mac client as well. If you are doing this a lot, you may be having something like Homebrew, which is a package manager installed, so you can just brew install Git. If anyone wants to do a BOF about Homebrew, be glad to talk about that more, but it's really a great way to be able to install things without having to mount disk images and try and drag and figure out where to put it. And usually they end up with instructions like, now take this line and add it to your bash profile. And you're thinking, well, that'd be nice if I knew what a bash profile is, but Brew will actually do a lot of that stuff for you or give you very good instructions on how to do it. So Git is really command line. Sorry, let me step back a sec. Git is really command line oriented, but there are some really good GUIs out there. Tree Source, I think it's called. There's a new one called Git Kraken. So if you like the mythology stuff, it's pretty fun. It shows you, we'll get into what branches and all that are, but it shows you a pretty good map of how things work. A lot of IDEs now have Git or other things built in. So Atom, Sublime, PHP Storm, a lot of them have it built in. So that's getting a lot easier too. There's really only two things you need to do to get set up once you've installed Git. And one is to tell Git what your name is and what your email is. And you can override these for each project. So for example, at Acquia, my machine is set up with this being my Acquia account. But then if I'm doing just purely Drupal.org, work on my own time, I'll often just have it set to my my Gmail account because that's what Drupal.org knows me as, so that helps with the attribution. This isn't anything that it's going to mail you or put you on lists or do anything. It's just for when you make a commit. This is, it looks like the header for an email, and we'll see an example of that, but it just helps identify you so that people know who was doing what. And once you've done that, initializing a new repository on your machine is one way to get started, and this is the command. The command is basically just git init and where you would like it to be. So that can be a path, so it could say /temp/myrepo or whatever you want to call it, and wherever you'd like it to be. If you don't put in a full path, it assumes just the current directory and creates a folder right there. Some important things about Git. Now this is where we started to get into what Git really is doing. So this is the fun part. It has a working directory, which is what you see in your Finder, what you're looking at, what you open up and edit. Those are the files you're working on. It has a repository, which is kind of where everything gets stored once we commit it or save it into Git. Not just saving it to disk as a file through the file system, but saving it into Git, and we'll show that in a bit. But typically that's in a Git directory, a hidden directory in your in the directory you specified before, called .git. So you can just cd into .git and look to see what's in there if you need to, and you can take a gander at what all the files are. They won't make much sense for a while. It took me a while, but the repository is kind of the end-all where things go. And then, let me get back, sorry. And then there's a middle area. This is kind of the fundamental thing of Git, is called a staging area. And what this is when you have finished making all your changes on the system and you want to commit them to the repository, you don't need to commit all of them, so you move the individual changes into a staging area, and then when you commit, it takes everything in the staging area and commits it as one commit. So you may change 3 or 4 files for one change and commit them all as one commit, so that if somebody has to undo it, they only have to undo one thing. Or if 2 files are tied together, if you're changing an HTML file and a CSS file for something, then you can stage them both and commit them as one commit. All good? All good. So this is kind of what it looks like. When you have a repository already, checking out a repository basically means somebody's already set up a repository. It's not just been in a init, but somebody's already done work. You want to get Drupal.org's Drupal's repository. You can do that, and when you check that out, it creates a working directory of whatever you told it to check out. And the working directory just looks like the files you'd expect when you download the tar file or a zip file of Drupal and unpack it. Except that there's this .git directory that has all the history of it. The nice thing about doing that for Drupal, for example, is you can switch versions of Drupal very easily. So you can switch from Drupal 7.43 to 7.44, or from 7 to 8 in your directory very easily. So if you're just trying to look at files, the whole history of Drupal, you can actually check out Drupal 3 from the Git repository, and good luck trying to get a Drupal 3 site up and running. It only works on PHP 4 or maybe 3, and MySQL 4 if not 2. So it doesn't understand most of what we use today. But you can see the code, and you can see how Drupal has progressed over the years, all in right on your laptop. So like I was saying before, the working directory is where you have all of the files that you're normally working on. These may be module files, CSS files, theme files. I just used two different colors to say that I've made changes to a.text and d.html. Those are obviously made up names, but what happens is when I have the repository that's got all the old stuff, let's say I've made these changes and I want to save the changes that I made in A, but D isn't really, I just had to change something that didn't matter, that I don't want to put in the repository yet. So if I just add A, it makes a copy or a pointer to the A file in the staging area, so that when I commit it, it commits only A to the directory, to the repository. So what you add to the staging area is what gets committed, not all of the changes you've made. It's not a full snapshot of everything you've changed. So if you have to change your settings file to have a different database connection to work locally, or if you have extra modules that you use locally but you don't want to commit up to the web server, you can just not add them, and they will never get to the repository and therefore not be shared with everybody else. That's something you decide usually as a team, whether you want to just not enable the modules or not ever actually have them. And once you've committed, then your staging area is cleared out and the changes are actually in the repository now. But Git has the history that A actually had a change in it, so you can flip back and forth between the two, and I'll show you how to do that. You can also do the same thing with multiple files at the same time. Like I said, if you add them, they all go into the staging area, and then one commit will copy them all into the repository as one commit message and one thing. So if you undid that commit, you'd be able to undo all of those changes at once, because usually we don't touch just one file. We have a whole bunch of things that we need to change. Keep using the word commit. A commit is basically just a set of changes to a set of files, and knowing what was before and what is now. And that's all it needs to know is where was the parent, like where did we start from, and what did we change? And that's known as objects and trees, but you'll sometimes hear those. You don't really need to worry about objects and trees because they get combined up into a commit, which is almost like a little library card that says this file was changed and this file was changed. It's these versions of the files, and they were changed from this state, this previous commit here. So commits happen one after the other, and you just keep changing files, and it says, well, this is where I was, and this is where I am, so it now knows how to check the difference between the two of them and move on. The git commit is really just git commit. Most people add the -m flag and put the commit message right on the command line. If you don't do that, if you just say git commit, it will open up an editor, whatever you have set as your normal editor, which is usually either VI or Nano. Some people change it to be Notepad or text edit or TextMate. You can configure all of that, but to avoid opening an editor and then having to save it when you're just trying to write a sentence, most people put the commit message right in the command.
Excuse me,
yeah.
Question. So when you git add
yep.
a file, and let's say after you did that, you had some other changes.
Yeah.
Those other changes don't get saved until you commit, right? You don't have to do another git add.
So I can do git add A, and then if I then change git file B, if I commit now, it's only going to commit A because I haven't added B.
If you change A after you've added it.
Correct. It knows it takes a snapshot of the file when you add it. So then if you then go back and change A again before you commit, it will change the first one because it does make it basically copies it, gets it all ready to be what it's going to store, and then the commit just decides how many of them it's going to do at once. So if I add and then edit and then commit, I get what I added, not what I edited the last time. That's kind of a weird workflow, but Git will also tell you that you did that. It will say, hey, that's probably not what you wanted. It may be what you wanted, but it will remind you that you have a modified file that is not in the staging area. And it may tell you that it's in the staging area and modified and not in the staging area, which means that you added it, but you've also changed it and not staged those edits. All right. Every time I lose screen focus, so it's hard to click. So the commit message is really for you to imagine going back 3 years from now and looking at your commit message to try and decipher what this commit was for. Fixing things is not a good commit message. This is one of the fun things we do in support, and people do it all over the internet, but people's commit messages where they're asking us to help them debug what went wrong, and they have commit messages like, well, that didn't work, and trying again, and well, one more time into the breach, here we go, and things like fixed the file. You can then go in and actually look at the commit to see what it is, but usually you want to give it a pretty concise but informative message about what it is you were trying to fix. These can be paragraphs long, they don't need to be, but usually a good sentence. Now, if you're using any kind of a tracking system like Jira or a bug tracker or some sort of project tracker, we always commit with the tracking, the Jira issue number that we're fixing as part of the commit message. Drupal.org, you always want to commit message with the name of the issue or the title of the issue that you're committing. Drupal has a little bit different things because Drupal uses patch files and they want you to name the patch file a certain way so that they can keep track of them. But most places, it's not the file you generate, it's the commit message that you want to pay attention to. So you'll see a lot of these things where you get really funky numbers. They're just hexadecimal hashes. They're unique identifiers so that you'll never duplicate a hash number. And they're actually, fairly long. But you can shorten them down. And you can shorten them down to 6 characters, or if you have 100,000 commits in your repo or 100,000 hashes in your repo, you may start to overlap at the 6 characters, so you have to go out as far, and Git will tell you that's ambiguous, and that means that I have 2 commits with the same first 6 characters, so you got to be more specific. Often people just end up cutting and pasting this because you can just double click and copy, and you can use the whole hash, but often you'll see them shorter. So if I had the hash 7200E3, or sorry, 7720E3, that is this commit, unless there's another one that starts with that. So if you see long and short names, you'll often see the same thing. So back again, this is where we get from the git config that we set up early. And then it just tags time, and then the git log would actually show you the commit message as well. I truncated this a little bit because this is actually a slide about tags. Tags are really, people talk about branching and tagging in Git, and it's really, don't think about it as branching and tagging, think about it as commits and tags. Because a tag is really just a friendly name for a specific commit. So you want to just point at it and say this one and put a sticky note on it and say this was the commit we had released on Saturday. This is a good way to do it because you can tag it with a name, and you don't always have to remember the hash number. So tags are really just the same as a commit. It's just a way of naming a specific commit, something helpful. However, branches, which is what you hear about, are different. And a branch is a line of commits. So we saw before that commits go out one after the other. A branch is the ability, just like you'd think it would be, is to diverge from the main branch and continue a new line of commits to be then able, one would hope at the end, to bring them back in to the fold. So it's like taking your copy of the files and working on them, making your commits, doing what you need to do, and then bringing it back to the main project. You'll hear about the master branch in Git, trunk in SVN, but the master branch in Git. Nothing special about the master branch, except that that's what it ships with when you do a git init. That's what it creates. That's what you start with. There's nothing about it in terms of Git that is different from any other branch, except that it's named master and you get it for free when you start. You don't have to create it. If you've listened to Dries' recent keynotes at cons and things on some of the topics, they talk about feature branches. And this is the way Drupal is going to start doing some of its work. Branches are great for experimenting because what it means is instead of just, I have an idea and I want to try something, instead of making a commit, which now I've kind of made history and I would have to undo that history to be able to do it, the better way to do it is when I think I want to try something, I'm going to start something new, I'm going to use this command called git branch, and I can give it any name I want. This is just my memory, what I'm trying to get done. And I can say, okay, check out that branch. And check out means which branch am I going to work on? So you may have 5 or 6 branches in your repository, and it's just where should I be right now? And a branch is just a series of commits, starting from the very first commit to wherever it branches off. So it includes the whole history back along that one line you can trace. And if I make a commit here, it's not affecting the master branch. It's not making commits that are going to affect anyone else. Why is this important? Back to the demonstration of what got me fired. If I make a series of commits and Pat has made his commits and gotten them approved and signed off on and put them into the master branch, now if I decide, whoops, my stuff is completely wrong, like let's forget I even had this thought, I can run a command like -D, which is delete, and all of my stuff goes away, as if it never happened. You'll also notice that I never had Pat's commits in mine, so I don't have to worry about whether his stuff is breaking mine yet. I can keep working on mine and be certain that I'm just working along. Testing and merging afterwards is kind of the harder part about Git, but it's also the nice thing. When you do these feature branches, you can pull them together before you push them to a remote repository so that everybody has them. And that's known as merging, pulling your branch back into another branch. And usually what happens is I made that branch, I made a bunch of commits, Pat got his commits, somehow they ended up in the master branch. They probably started in his own feature branch and did this process, but let's say he's farther along and they're actually in the master branch. When I check out master, it means that my computer is now my computer is now right at this commit. These commits are gone from my working directory, but the changes are still there in the Git repository because I've committed all of these. They're just not visible right now. But when I say merge and then the branch that I used to be working on, what it does is it takes all of those changes from fix users, brings them into where I am right now, bundles them all up and brings those commits in and creates what's called a merge commit, which is a separate commit that's basically like I know we had these two, but let's grab these three, and we're all going to bring them together and be one happy family, and here's where we did it. So merge commit is so that you can see when things got merged in. And that's a little tough of a concept. That's what kind of screwed me up at the very beginning, but it really is kind of important to see that what happens is, now, even though I'm on the master branch, and these are on the fix users branch, this commit says, look at all of these for the state to be in right now on master. Yes?
One of the things I wanted to know about merge commit is there a way of going back and checking to see which one merged?
Yes. Yes. It's called bisect. I'd love to show it. Let me see if we get a little time at the end. I don't have a slide for it, but we can do some live demoing of that. I don't get quite that far. You can do a couple different ways of doing that, but get bisect. Angie Byron, Webchick, has an old but still useful blog post about it on how to do it. And it's basically just, I have commits that are here. Let me, I know this one worked. I know this one broke. So bisect just says, okay, let's go to the one in the middle. Is it still broken? Yes. Let me go this way. Is it still broken? No. Let me go this way. So it just keeps trying to bisect you, like find a commit in the middle, and it just narrows you down to which. And then you can be like, well, it broke here, and it didn't break, and then it broke. So it must be this commit because there's nothing in between them. Git bisect is pretty cool that way. But let me get back to merge. So this merge commit is kind of weird because it looks like it's, two different branches and things combined, and it's hard to figure out. Usually once you've merged a branch, you don't need it anymore. You probably don't want it anymore. So you delete it. And you'll notice here that the lowercase d for the merge or the branch delete, that lowercase d is what you should be using because that says only merge this if it's safe. In other words, only delete this if it's safe. In other words, if it's been merged into another branch. If I haven't merged it and I use the capital D, literally I just threw everything away in my branch, which is fine. After you've merged, if you do the lowercase d, it does not lose these three commits. It just says, well, there's no longer a separate branch for them. They're just part of master because that's where the commit, the merge was on master. So they basically just move up and become part of the master branch. And they were before. They were just kind of in both places at once. But it knows about both branches at once before you delete your feature branch. So this is why it's nice to kind of clean things up. When you're done and you've merged back into master, usually you'll go ahead and remove your feature branch because you wouldn't have committed it to master unless it was done, right? So you can keep going on your master branch, on your feature branch until you're ready and then collapse it up. But what happens if master has progressed while you've been doing your changes? You can't merge easily back into master, or you shouldn't merge back into master unless you've checked to make sure that all of the new things in master haven't broken what you've done. So if you remember my example, Pat and I were both changing two different lines in the CSS file. What if we were changing the same line? What if he was changing color to blue and I was changing color to red? For whatever reason, we would be in conflict there. And you'll end up with what are called merge conflicts. And they're a little harder to work through. You can easily because it'll just say there's a conflict right here, and it'll actually edit the file to have here's where the conflict starts, here's where the conflict, your piece, Pat's piece, fix this and then save it because you need to make a manual decision. There's no way for the system to know whether it should be red or blue. That's really just something that you should have communicated about better, but merge conflicts will happen that way. So a way to keep those to a minimum is something called rebasing. Now you remember that when the term is cut my branch. So when I cut my branch from this commit, wherever the repo was at this point, I start working and whatever changes I make, that's what I see in my working directory. But Pat has added a couple of new things. I need to make sure that his things and my things don't collide. So instead of doing a merge or I merge into some temporary branch to see how it works, what I can do is what's called a rebase, which says, okay, basically undo my work, go back to the top of master, the tip or head of master, and put all my changes back on as if I had done it from this point. So instead of Tuesday's work, I start on Thursday's work. And if Pat had made these 2 commits on Wednesday, then it's as if I had thrown away all my changes, gotten a new copy, and put all my changes back on. So a rebase says redo the base being where the commit, where your branch is branched from. So my base here is this white commit. That's a known thing to get when you say branch fix users. It says, okay, the base is this commit, whatever the hash is, and it stores that so it knows exactly where the base of the branch is. And if you say, okay, well, let's go back and check out and rebase, what it says is, if you weren't already on the fix users, but when you say rebase master, it says, whatever branch you're on, take all the changes from it, hold them, set your base back up, and replay them. And so that essentially is combining them all together. Yeah. So the merge will do a secondary commit, like it'll make you make a commit message, and it forms a new commit that keeps them. It keeps them separate, but with tracking, so that you know where they came from, which branch and what pieces they came from. And what I would do for this case is actually, if I was going to merge it, I would do it the other way from the description that I had. I would merge master into feature branch, because my feature branch isn't ready yet. I just want to make sure I'm keeping up with whatever changes that has happened to master. So I'm not trying to commit it back into master. I don't want to commit master into mine, because then I've got this extra commit in my branch that I don't need that dark red commit or merge commit here. Basically, I just want to act as if this all happened kind of instantaneously. So rebasing is sometimes called cleaner. Yeah. Yep. Because the conflicts will happen because Pat made a change to the same line I was trying to make in this one. It will actually get partway through the rebase and tell you the same thing. There's a conflict, and you have to self-correct it and then say, yes, this was the right way it should have been. And then your commit actually changes. So it'll actually, it'll figure out which should be and edit your commit. So this is where the problem is with rebasing. The golden rule of rebasing is never rebase something that has been shared to other people. So in other words, I'm working on fix users, so I shouldn't rebase if I've pushed my fix users out to other people, unless we're all very close and very careful about what we do. And the reason for that is because I wiped out those commits. I kind of held them off to the side, but I wiped them out, reset my head, and then literally made new commits with the same things, just played them over again. But they end up with new hashes, and they end up as new commits because they're slightly different. You know, they may be changing. They have slight differences from what they're changing. Boy, this is annoying. I should have changed my screen timeout. I usually have battery. I'm running on battery, which is fine. But does that make sense? If you share this, and I have the old set of commits that are based off of the old branch, it's hard for me then to update this fix users if it's already been, if the history is there, because I have to basically wipe out my whole history and replay it again. So there are ways to do it, but you can't just use the normal tools of git pull, because git pull is really trying to do just from here out, not rewind and play everything again. which is what a rebase is. So it's great on a local, and it's great to kind of catch yourself up to other branches, but you don't want to rebase upstream for things that have been shared publicly. That's really what it is the idea of don't rebase unless you really know what you're doing, or the branch you're on hasn't been pushed to a remote and shared with other people. Like it's not public. It's a good rule. You can get around it. You can undo that. You can certainly, we do it when we push feature branches and have other people collaborate on them, and they're like, no, we should make this, this, and this. We'll redo it, and we'll force our changes and make our branch rewrite its history. But that means that anybody who's checked out that branch to help work on it has to basically scrap everything and get it again. There's just some commands for that. But if they've been working on it as well, then it's really hard because it doesn't know how to merge. It doesn't know how to interweave all of the changes they've made with all of the changes we've made without basically going back and looking at everything to try and see where it is. We can work on it more. It may just take a little while to sink in, but rebasing is usually, people throw up horror stories, but it's almost always when they've pushed a branch and then try and rebase. So let's talk about remotes, and maybe that'll help with a little bit of what push means. But we showed this slide before. That remote repository or Pat's repository are what are known as remotes. I can even have a remote on my own laptop, but it's basically just another copy of the file of the Git repository that I want to talk to as something. The way you do git remote is there are a whole bunch of commands that are called subcommands of the remote command. So git remote, and then you give it add, a name, and some sort of URI. GitHub will give this all to you in what's called a clone, and I'll show you what a clone is. But you don't often have to do this. This is something I just want to kind of explain what the magic behind some of the other commands are. So git remote add, I'm giving it the name gith, anything I make up. But that is the URL that GitHub told me I needed because I went and created a repository on GitHub. I'll show you, there's a slide that talks about how Drupal does this as well. You go to the version control page of a module, and it will tell you what the command is to clone the module. But this basically just lets me name that remote repository gith in this case. I could call it upstream or origin or main server or whatever we decide to call it. In fact, your teams can all call it different things. It's usually good to standardize just so you can help each other, but that way the command is I can give you the command and you can just run it, but they don't have to be named the same thing. It's basically just so that you know where, when you say to push to gith, it actually knows what that means. Use this SSH command to talk to gith. Here's the path, and let's see if we can push my changes up to GitHub. So what am I trying to push? Well, you pass it a branch or a tag identifier, and it will take that branch and not merge it, not commit. It will just put the branch up on the remote as well. So it'll basically tell the remote that all these new things exist, including the branch or whatever merges you've done or whatever changes you've made that include that branch. So if I just git push gith master, but I've been working on fix users, my fix users stuff is not going up to the server by default. It's still local to me. So I may check something out and then somebody calls up and says, oh my God, there's a horrible thing and I have to switch to a new branch. I make the fix really quickly and then I merge that into master and push master up to GitHub. But I haven't done anything with fix users. It's still just local to my machine. So your repository is not necessarily a carbon copy of what's on the remote. They started at the same place and then you synchronize them with pushes and pulls. Pushes, obviously your changes up to the server. Pulls, you're asking for what other people have pushed up to the server. Git fetch just is really the command that says go up to whatever remote and tell me all of the changes that have been done, all the new branches, all the tags, and it doesn't get them. It doesn't literally like transfer all of the things. It basically just pulls down the card catalog, the index of the table of contents of what branches and what new things exist and what state they're at, so that you can then see messages like it will tell you, you are 3 commits behind the remote repository. In other words, people have pushed 3 more commits to the same branch you're working on, so you might want to pull. Fetch will update that index, but not actually pull them. Sometimes that's helpful, sometimes it's not. I'm not sure with how we started what the timing should be here. Yeah, thank you. That'd be great. We're almost near the end. So git clone is something you'll hear a lot. So if you're going to clone a repo from GitHub, you're going to clone the repo from Drupal.org. Clone is basically the same as doing an init, adding the remote, doing a fetch and pull and check out, and getting all that all wrapped up into one thing. So if I said git clone and then that URL, it adds that as URI, that it adds that as a remote. It does a fetch. It does then pull the master branch because, again, that's our default. It doesn't pull everything. It does a fetch, so it knows about everything, but it doesn't actually get the whole history, which is fairly nice for something like Drupal, so that you don't, download all of the objects that get you all the way back to Drupal 3. So basically, you're pulling from the remote and you're pushing to the remote at the same way. Sometimes you'll see people just say, well, do git pull. Git pull says whatever you clone from, it knows that what you started from is where you're synced up to, so it has some ways of being able to track things. So these are basically the git commands that we talked about. I'm going to push a little faster. Some of the ideas that people say, work on your branches, put a tag on production. A tag, remember, is a specific commit, so that even if people make more commits to that branch, your what's on production isn't changing until you tell it to. So you can't accidentally change what's on production. You always want to be deciding how to work, but people often merge into master. Drupal, for example, merges into their main branches. So we merge into 8.x, we merge into 7.x. So they have the major versions are the master branches, but they don't call them master anymore. Like I said, that's just a name that comes, but we don't use it. Here's a interesting, helpful thing though. Every project on Drupal has a version control tab that's very kind of subtle. But right there, you click on version control and it will give you the git command to check out that project. So you can do that and then get that project, and it also gives you a page of description on how to add commits, how you should name things, how you should patch things. I'll put these slides up, so these links you don't have to worry about. This is the end. I hope to be able to get to things. It sounds like we're running at the end. That's fine. So we can do more talk, BOFs, hallway, but I'm going to have to give up the podium for whoever's up next. So thank you, and feel free to catch me with questions, and I'll be glad to take them. And I have no idea if I need to stop recording things.